Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at the equation of a circle. Now you might actually be able to do the stuff in this video because you've probably seen it at GCSE, but we've got to cover it anyway. So let's delve straight in and I'm going to introduce you to the equation of a circle with a centre at the origin. Okay, the equation of a circle is always the same if we are at the origin, apart from what's on the right hand side of the equation. So let me introduce it or reintroduce it to you. If we are at the centre, that is 0, 0, the equation of a circle is x squared plus y squared is equal to r squared. Okay, where we've just got x and y, and where r is the radius of the circle. Okay, and in fact I'm going to move that down a minute just there, and let's do some examples. Okay, so one example could be x squared plus y squared is equal to 25. Okay, we've got a square number on the right hand side, so that is actually the same as x squared plus y squared is equal to 5 squared, and so the radius of that circle is 5. Okay, if we were to have a look at another example, we could have x squared plus y squared is equal to, I don't know, 16 maybe. We've got another square number there, that's actually 4 squared, and so the radius of that circle is 4. Okay, so there's some easy examples. So this is always the case. We always have x squared plus y squared if we're at the centre 0, 0. And then on the right hand side is the radius squared. R is the radius of the circle. So we've got r squared, that's the radius squared. However, if we have a centre at AB, so it's not the centre, it actually does work for the centre, but this is just a general point AB, anywhere on the graph or anywhere on the axes. If we've got that, then this is the equation of the circle. We're going to introduce some brackets. We have x minus a, we square that, we add y minus b, we square that bracket, and that's equal to the radius squared. Where have a and b come from? A is the x coordinate of the centre and b is the y coordinate of the centre. Okay, so all we do is we do the same thing here, but we have brackets and we just take off the x coordinate of the centre and we square that, x minus a, we square that, and then we take off the y coordinates of the y coordinate of the centre. Okay, we square that, and that's equal to r squared. Okay, again, where r is the centre of, sorry, the radius of the circle, so r squared is then the radius squared. Okay, I'll just bring that down there. Okay, so r squared is the radius squared. So some examples of that, let's just see 2 examples. So, example 1 first, that would be good. Let's say we had a centre, and let's say the centre was, I don't know, 1, 1, okay? And we had a radius of, let's say, I don't know, 17. Well, let's make it an easy number actually, let's say 10, so then I can square it in my head. What we want to do is work out the equation, so we would do x minus the x coordinate of the centre plus y minus the y coordinate of the centre, and then we'll do the radius squared, so 10 squared, and that's the same as x minus 1 squared plus y minus 1 squared is equal to 100. Okay, so that would be the equation of this circle. We have a centre at 1, 1, we have a radius of 10, and so what we have to do, take off 1 from x because that's the x coordinate of the centre, do the same for y because that's the y coordinate of the centre, and then square the radius. Okay? But why is it actually this? Why is that the case? And we can think about this in terms of translations. Okay, so why is it x minus a all squared plus y minus b all squared is equal to r squared? Well, let's say this is our circle and this is where AB is. Okay, so AB is just here. Okay, let's First of all, think about that, but also think about this dashed circle here. And this dashed circle has a centre. We'll draw it in black. The centre is there, and it has the centre at the origin, okay, so at 0, 0. What can we kind of do to connect these two circles together? First of all, let's think about the equation of this circle. So the dashed circle has this equation. Really, if we're thinking about it in terms of this, we take off 0, don't we? Okay, like I said at the start, this is always the case, okay? But really, if we think about the centre AB being 0, 0, we are taking off the centre, okay? We're taking off 0. So all we've done is just substituted 0, 0 into this equation. And of course we don't need to subtract 0 there, so it's just the form of the circle that I introduced in a minute ago. It's this form of the circle here, because we've got centre 0, 0. So that's the case there, and that's the equation of this dashed circle here. Now they're exactly the same size, so they have the exact same radius, and in fact, I'll draw that on there, okay? That's the same radius. Now, how can we go from, I'm going to do it like this actually. Let's just see if that's going to fill in. Probably not. Oh, it does. Perfect. Okay. How can we go from this dashed circle to the full circle? Okay, the straight line circle. How can we do that? So how can we basically, if you like, I'll do a little sketch here. How can we go from this circle here to that circle there? Well, like I said, we can think about this in terms of translations. So what we can do is we can think about it being a translation, and to go from the dashed line to the straight line circle, we can basically think about the centre moving, and as the centre moves, the whole circle will move with it. So the centre of this circle, to go to the centre of this circle, we can go a positive A in the X direction, and then a positive B in the Y direction. Okay, so it's a translation. We can go from 0, 0 to AB, the centres, we go A in the X direction, or a positive A, and we go a positive B in the Y direction. Now, if we think back to what the translation video, what that actually means is if we have a function, okay, so let's say we've got a function f of x, f of x minus a is a translation, I'll write it over here, it's the translation positive a in the x, and I've just put dir for direction, okay? And if then we've got that, if we think about that being the translation, what can we do from this equation, okay, to this equation? Well, we can think that we can do the negative a, okay? All we can do is kind of put a negative a with the x. This was the function, okay? We had a translation in the x direction, the positive x direction. So we do the opposite sign, we do a negative. So we can think, it's a translation, that's the first part of our equation, okay? With the x, we do a negative a because that's what the translation is. Think back to the translation part of this course, okay? Think about the lesson on translation. So we've got a minus a there, okay? We square it because that's what we were doing. We just replace x with x minus a, and that will move the x over here. No, not the x, the circle, okay? We'll move the circle over there. Then let's think about the y. Now the y is a little bit different. If you remember, to move it up with the y, we'd have a function. We would do f of x plus, and let's say it was b here, okay? That would be a translation plus b in the y direction, okay? So it wasn't inside the bracket here, we just added on to the function. However, we need it to be something like this, so we actually do it inside the function, okay? Inside the bracket. And that's exactly why the equation is what it is, okay? Because we can just think about it being translations. We move x, we move y, so xa, yb. So then we can think about taking it away, because that's what the translation actually means. Hopefully that makes some sense. That's how we can go from this equation to this equation. Okay, now let's have a look at some examples. The first example says write down the equation of the circle with centre 5, 7 and radius 10. Now, keyword, write down. We can just use the general form of a straight line when the centre is not at the origin, it's just at some point AB. Here we've not got AB, we've got 5, 7, and we can just write that down. So the form is x minus a all squared plus y minus b all squared is equal to the radius squared. A and b is the centre of the circle, so all we have to do is substitute in what we know. We know the centre is 5, 7 and we know the radius is 10, so let's just substitute. And the more you do this, the more you're able to just write down. The equation is x minus 5 squared plus y minus 7 squared is equal to 100. 10 squared. That's what that is there, okay? That is your answer. Really quite simple, you can just write it down. Okay, let's have a look at the second example. Here we are given the equation of a circle and we're being asked to write down the centre and the radius of the circle. So, pretty simple, all we have to do is just compare it. If we've got a centre, I'll call it C, AB, and let's say the radius is R. We're told we've got the equation of the circle x minus a squared plus y minus b squared is equal to r squared. So let's just compare it to that form. All we have to do is think, okay, the centre is going to be this number there without the negative and that number there with the negative because we take the opposite sign, okay? And then this here is the radius squared. So if we think this is r squared. So the centre is going to be 5 minus 9, because if we think this is negative 9, okay, if we substitute it into there, we want it to be a positive, so we need b to be a negative, we need the y coordinate to be negative 9. And then the radius of the circle, this is r squared, so, and r will be, well, we don't want r squared, we want r. We're going to square root the number here because that's r squared. The radius squared is 20, so what's the radius? Radius has to be positive because it's a length, so it's going to be the square root of 20 and it's the positive square root. Okay, that's your final answer for part A. There's the radius and then there is the centre. Okay, so quite straightforward so far. Part B says show that the circle passes through 9 minus 7. So all we have to do is substitute in 9 minus 7 into that equation. Okay, so again, quite simple. Let's do it together. So substitute. This is going to be our value for x and this is going to be our value for y. And because we're trying to show that it passes through the point, or the circle passes through this point, we want the equation to work for that point. So when we substitute x and y into here, we want the equation to be equal to 20. Okay, so let's write down the equation. We've got x minus 5 squared plus y plus 9 squared is equal to 20. Okay, substitute our x value in of 9. 9 minus 5 squared plus our y value of minus 7 plus 9 squared is equal to 20. 9 minus 5 is 4. That's going to be 4 squared plus minus 7 plus 9 is 2. Square that. Is that going to be equal to 20? Now, I'm going to put a question mark along here because we don't actually know if this is a show question. So we're just substituting in and hoping that this is equal to 20. That doesn't really look like 20, does it? Let's improve that a little bit. 20. Okay, so let's work out. 4 squared is 16. and then 2 squared is 4, that equals to 20, so we have 20 equals 20 on the left hand side and the right hand side, so that's correct. Hence, the circle passes through 9 minus 7 because it works for the equation. When we substituted our x of 9 and our y of 7 into here, the right hand side and the left hand side were both 20. Okay, we can see 16 plus 4 is 20, and that's what our equation is equal to. So it works. All right, let's have a look at another example, and I think it's the final example for this video. It is. So this one's a little bit different. Pause if you want to, but we will work through it together as always. So example 3 says, find the center and the radius of the circle with the expanded equation. So keyword here, expanded equation. This time we don't have it in the form where we've got the centre being AB. Okay, we don't have that. We have an expanded equation. Think about how we can go from an equation like this to an expanded equation. Well, expanded we kind of connect to expanding the brackets. So think about how we can maybe get this into expanded equation form, okay? Well, we'll just expand the brackets, and it's going to give us something like this. Not similar numbers, it'll be different numbers because this is a different question, but that's what expanded equation is, where we expand the brackets and we collect our like terms and get it looking something like this. So this is actually an acceptable form of a circle. It's just the expanded version of the equation of a circle. But we want to find the centre and the radius. It's not very easy to read off the centre and the radius of a circle. We want to get it into the form, and I'll write it here. So let's put it in brackets. Let's put it as a hint, actually. We want to get into the form x minus a squared plus y minus b squared is equal to r squared. Again, where a and b are the equation of the circle, so a comma b, and r is the radius. Okay, so think about how we can go from some expanded form here, collect your x's maybe, think about what we can do there. So pause and have a go if you want to, and then we'll work through the answer. Okay, let's see. If you didn't get the answer, don't worry. These questions do come up and they're actually quite easy to do, because if we don't think about it in terms of circles, we can just think about it in terms of completing the square. So maybe some of you got that, I don't know. But what we're going to do is we're going to collect our like terms first. I'm going to put all the x things together. I'm going to put all the y things together, and then I'm going to have my constant on the end. So let's do that. We'll have x squared minus 14x plus y squared plus 16y minus 12. Okay? And then I'm going to complete the square. So to do that, we'll complete the square on the x parts. So we'll have x minus half our x will be 7. Square that and take away 49. Okay? If you're unsure about completing the square, have a look in another video. And then completing the square on the y part, I will have y plus 8 squared, take off 8 squared, which is 64, take off 12, and set that equal to 0. Then when you collect everything together, you'll have x minus 7 squared plus y plus 8 squared is equal to, and on the right hand side you should have, let me have a look, you should have 125 just by adding the constants and taking them over. So we can read off that, I'll call the centre C is 7 minus 8, sorry, by taking the opposite signs from there and there, and then the radius will be the positive square root of 125. So completing the square is actually a really cool trick. Collect your x's together, complete the square on the x's, collect your y's together, complete the square on the y's, and then just collect all your constants together, Here we've got r squared, so this then, the positive square root will be r, and then we're going to take the opposite signs here. A and B is our centre of the circle, so we've got opposite signs here, so the centre will be 7, not minus 7, it will be 7, and here we've got a positive 8, so it's going to be minus 8.